Hi everyone, in today's episode I'm going to show you how I've implemented the car's sensors so it can be able to know how far or close it is to the track boundaries. To start, I decided to give the car a 90-degree field of view. To simplify this even further, instead of checking an infinite number of lines that are composing that quarter of a circle, I'm restricting the checks to only 5 lines like so. As we previously said, the track is composed of a bunch of polygons. The idea will be to check for each ray if it has an intersection with any of the track's boundaries. In order to see how far the car is from the track boundary, we need to check if the two lines are intersecting. Let's start with one ray and one track boundary. Let's say we have these coordinates x1, y1, x2, y2, x3, y3, and x4, y4. First thing, we need to calculate two constants called t and u that are represented by these formulas. If we only need to check whether the lines are intersecting or not, t and u should be between 0 and 1 inclusive. In our case, we want the intersection to be on the black line segment. So we need to check if the value of t is between 0 and 1 and u is positive. Imagine for a second that the track boundary is on the left of the ray. As we can see, the lines are intersecting at some point. However, the intersection point is in the opposite direction of the ray's direction, and in this case, we should say that there is no intersection. Let's go back to our previous example. So obviously, the ray and the track boundary are intersecting in a point with coordinates x and y. In order to calculate these coordinates, we can use one of these two formulas. Another thing I'm checking is the distance between the origin point x3, y3 and the intersection point. If that distance is greater than a constant that I've called max distance, I'm assuming that there is no intersection. Let's have a look at the code I wrote to get the intersection point. Now let's get back to the track. Imagine that the car is approaching a turn like so. This is the sensor. Let's cast it to all the boundaries within the max distance. We'll have a first intersection, then a second one. If we consider the sensor as a ray of laser light, the light will only be casted to the first wall, and the second one will not receive any light. Same thing here, we'll have to check the distances to both intersections, and we'll consider the nearest boundary as the one the ray is intersecting with. Let's have a look at the code. In a nutshell, for each ray sensor we need to iterate over all the track boundaries. The intersection point will be the nearest point to the origin. Last thing to do is to extend the car's update method to connect the sensors. We'll need to add two methods. The first one is to update the sensors each time the car coordinates or heading change. And the second one will be the look method we just saw to check the distances from the track boundaries. Notice that I'm only calling this method when the car is on the track. There is no actual need to read these sensors otherwise. With this, we reached the end of today's video. In the next episode, we'll see how to create the neural network which will learn how to drive the car. Thank you for watching and see you next time.